industrial design basically is concerned with multiple aspects, designing of products, systems, services, particularly from the point of view of manufacturability, from the point of view of usability, from the point of view of aesthetics, from the point of view of functionality. So, industrial design process actually looks at multiple aspects of product design life cycle in a very holistic way, and at the end of industrial design process, what happens is you add a value and also give an experience to a product or a services which is being designed. And it is a very integral process of many of the innovation program, product design programs, and also a part of entrepreneurial programs. In fact, many of the industrial design aspects, when they were not addressed as a part of new product development or innovation programs, we have seen that there have been many failures in the market, and hence it becomes a very, very important aspect to know industrial design and incorporate that as a part of our innovation process. Now, before we actually proceed to the case study, let us also recall we already discussed about the Designs Act 2000, which is basically Government of India's main act for registering designs as a part of intellectual property. And we have also seen that the Design Act basically covers industrial design aspect, which includes primarily the shape, the configuration, the ornamentation, the colors, and also the configuration of the components within the system as a part of this particular act. And we will also see later as a part of the case study that how these are realized during a design process, and particularly the act concerns with objects which are the artifacts, whether it is 2-dimensional or 3-dimensional, as they are seen particularly from our eyes. So, there is a lot of importance which is actually given for the visual aspect when it comes to the design, and that aspect we will see as we move along the case study. So, now let us move to today's case study. So, today's case study primarily is concerns with design of assistive products. So, in this particular case study, we will take two assistive technologies. Assistive technologies are technologies which are actually used by people with disabilities or elderly as a functional substitution. And in today's case study, we are particularly looking at assistive technologies for the visually challenged as a part of that. And we will also see that the case study will bring the relation between industrial design and intellectual property in a very strong manner as we go along this particular journey. So, let us take the first design case study, which is related to a product which is called as a smart cane. So, smart cane is a product which was invented a few years back, basically to address the problem of mobility or independent mobility for visually blind people. If you really look at the mobility of blind people, all of you may have seen the blind people using a white cane, which actually helps them to basically navigate and also overcome obstacles in their path and negotiate these obstacles to find a path to their destination. And white cane is a wonderful device, is in use for many centuries, and has helped millions of people in basically obstacle free navigation. However, the white cane which is commonly used by blind people can help in detecting obstacles which are typically up to a knee height. Whenever we have obstacles which are from, let us say, knee to head height, such as the one which is actually shown in this particular example, usually people only come to know when they actually move and when they come across the obstacles or when they actually hit the obstacle. And in such cases, the white cane cannot actually perform the obstacle detection function, and usually people have upper body injuries, and there are also injuries which happen to their heads. And particularly in many of the countries, including India, finding such obstacles on their pathways is very common, and hence a white cane is not sufficient for an obstacle free navigation in countries such as India and 90% of the world. So, one of the solutions which has been proposed for this type of problem is to come up with what is called as a smart cane. What is shown here is a first version of a smart cane, where you will see a visually challenged person using a white cane with a sensor which is also mounted at the top of a white cane. This particular sensor actually, which uses ultrasonic sensors, helps them to identify obstacles which can harm upper body injuries and to negotiate those obstacles. And the presence of obstacles is generally prompted by a vibratory feedback which user receives and hence get alerted or changes the path in order to overcome an obstacle. So, this is a typical example of a design process where there is a need and then there is a solution which has been proposed in terms of sensors and the obstacle detection system, which is called as a smart cane. But what you are seeing here is a version 1 of a product. In version 1 of a product, when you are actually doing an industrial design process, initial concentration would be to basically look at the proof of concept. And at the proof of concept stage, one generally people do not think of filing a design registration, because it's very clear that this particular version is going to undergo multiple changes, and probably the final version is something which is worth protecting, and that is a process which is commonly followed in all industrial design processes. Now, when this particular cane, smart cane, was given to a people, it also went through a multiple iterations. For example, initially the problem which came was about having a heavy mass at the end of a cane, which actually made people very uncomfortable in using the smart cane. Then the design of a smart cane was changed to balance the masses and to give a trouble-free navigation or a trouble-free holding of the cane in order to move around basically the places where there are obstacles. So, what you see here is a second version which is very different from the first version which you saw in the previous slide. And when this was actually given to people, it actually kind of worked better than the previous version, but people found that even this is not very optimal, because people use very different type of grips. What you see in this particular picture is people are using 4 different ways they held the smart cane or a white cane, and this particular design is not suitable for all types of grips. It is actually designed for one type of a grip, and hence when this particular product was actually taken in the field, people gave a lot of feedback, and it was a time when industrial designers would come back and redo their design in order to incorporate all aspects of the grips. And then it went through a few iterations. As you see here, these are some of the ideations which were done, some of the new designs which industrial design people came up and then gave it to people to try out, taking continuously feedback. So, in any industrial design process, it is very common to have these iterations. Usually these are called as design, build, test, fail and modify iterations. and unless it goes through few failures and modifications, usually the product or a design is not refined, and this is a process which is very commonly followed in all industrial design houses or by all industrial designers. So what you are seeing here is variants of basically the smart cane with various grip geometries given to people, and then finally one of the better grips or one of the versions which came up was a sleek smart cane where people even with a smaller palms can actually hold and actually can use for the navigation. So this is the version which industrial designers came up after analyzing all the grips and came up with this sleek cane and which was given to people to try out, and most of the people with various grips felt this as a very comfortable smart cane. However, when this was used for longer hours of typically of 1 to 2 hours duration, people still felt some uncomfortable feelings, particularly in their palms, and some parts of their hands and palms were actually paining when it was used for a very long duration. So keeping that in mind, another iteration was carried out basically for a long-term usage. For this purpose, industrial designers actually analyzed the pain points of users, variety of users and variety of grips, and found that the regions where there are pain points, if the geometry can be modified and if it can be ergonomically designed, the cane can be made more comfortable even for the longer duration of usage. And with these analysis and also carrying out a lot of trials by building various forms, geometries using materials such as clay, number of trials were carried out. Now this also gives an example. If you recall, when we discussed about the Industrial Design Act, we also spoke about the mainly form is one of the important factors. What you are seeing through all these slides is that how the form is continuously being evolved, considering more and more important requirements which the product is expected to fulfill. And in this case, you see a form which is very different, which is very ergonomic as compared to the previous ones, which arised out of a lot of user trials, user feedback, and then going through a modification. And these new geometries were again tried out with a variety of users, and the feedback was obtained for shorter and longer duration, and based on this particular one. So what you are actually seeing here is the final version of the smart cane, which came after almost like 10, 12 iterations, and the one which actually for which the design registration was filed. This is the final version which has been validated for all aspects of its form, and this is the one which is now in the market. This example also gives you how the form explorations are done from the very version 1 when it was built for a proof of concept, taking care of various life cycle issues, various aspects of a smart cane, and arriving at a fairly complex form. And the value addition which has gone in arriving at this particular form is very clearly evident through all those iterations, all the time spent on those iterations, and all the money and the manpower which was involved in arriving at this particular form. And hence, the value addition which has gone in arriving at this particular form becomes extremely important and needs to be protected, and that is the time when the design registration was filed and it was actually protected. So in this example, we have primarily looked at more from the form exploration side. So why the design registration was filed? If somebody asks me in summary, the main reason is, as we said, it went through a very long value addition process, and if someone can copy, then they can actually get a very optimized form without going through these iterations. So which is actually not correct, and hence the person who has actually built the value should get the ownership, and hence the design registration becomes a very important aspect. The second important aspect of design registration is that whenever you protect it as a design registration, it kind of gives a confidence to investors to particularly invest in this as there is a protection, and it also gives kind of confidence and value to manufacturers that in case they end up, or in case they get the license for this particular product and end up manufacturing, that they do have a protection in the market. Now, those are very important considerations which sometimes are not discussed as a part of a industrial design and design registrations, but I think one should keep this in mind. But the third, which is very, very important aspect which we came across, is that if you don't protect this type of endeavors through design registrations, you will soon see lot of imitations of this particular product, and the products which actually imitate this one may end up with products which are very high risk, or they may not be as reliable as possible, and it may even endanger the person who is actually going to use. Hence, from the safety point of view, protection of such products through a design registrations becomes extremely mandatory, and thus it was decided to have a design registration for this particular product. Now, this particular product, since it went through a very rigorous industrial design process, it was also kind of accepted by the users, and there are more than 1 lakh users of this particular product in India as well as outside India. And one good thing which also happens because of rigorous industrial design process is that you also making the product very simple and easy to use, and which adds a lot of value not only nationally but also internationally. Because of this reason, you will also find that the product has been appreciated globally, and it is chosen for display for its design at various international forums. For example, the one which is on the left is Discovery Center at Bill and Melinda Gates Foundation. The one which you see in the middle is the Scotland National Museum, and the one which you see on the right side is also displayed at Smithsonian Design Museum in New York. So, industrial design not only helps in building a value and protection, but it also makes the product very, very simple, as we could see in this particular example. In this example, we have primarily looked at form exploration. Form is a very important protection aspect of an industrial design. In the next example, we will actually go beyond form and also look at colors and configuration as an example. The second example, which is actually covered here, is called as a dot book, which is basically a refreshable braille device, again used by the people who are visually challenged. Now, many of you are familiar that the blind people use braille as a medium for communication, which is a very powerful, where all the text is converted into braille and people can touch the braille dots in order to understand what is being communicated, and they can also read and write braille to communicate with the people, which is a very common and widely used mode of communication all over the world for people with visual impairment. However, if I have a, let's say, a long book, or let's say a large book with lot of text, when I actually convert them into a braille version, it actually becomes extremely bulky. And secondly, what we see these days is that lot of literature which is now available is in the form of primarily digital text. So, in order to access a digital text, one of the commonly used device is called as a refreshable braille device. A refreshable braille device is one where the braille dots actually pop up and down as shown here, and people can refresh it any number of times in order to read or let's say to basically look at the contents of a digital text. Now, such refreshable braille devices are there in the international market, but they are not very widely available in India because of their cost. Hence, this particular team decided to do a affordable version of a refreshable braille device, and hence the process of design and industrial design actually started. Now, what is shown here is some of the very early versions of refreshable braille device, which is shown here. If you see here, there are only 6, 8 or 10 characters of the braille which are displayed in this. Now, these prototypes are made not from the industrial design perspective. Again, these were made more from the proof of concept perspective. So, the proof of concept is generally tested through a small prototypes which are not necessarily aesthetically pleasing and not necessarily very usable, but as one goes along, people build a value of usability and let's say aesthetics as a part of a industrial design process. Now, after the initial proof of concept studies were successful, this product was actually taken for the next level of industrial design. The next level of industrial design would involve looking at the configuration of the product, also look at the form of a product, and also third, which is very important, is what should be the color of this particular product or color of the keys. These are generally decided as a part of the industrial design process. Now, what you see here is typically lot of soft prototyping is done in order to explore multiple configuration. When we say configuration in products such as this, it also basically means that where the key should be located, how will the user access these keys, where should the display be located, how will finger explore the refreshable braille display, and what is the interaction which the user is going to have with this particular product, and in this particular interaction, what is something which is more usable, which is more experience based, is generally decided as a part of an industrial design process. So, people generally build soft and hard prototype in order to explore multiple configurations. For example, what you see here are 3 different configurations which were built through soft prototypes and were given to people to try out to see which of these configuration actually works better from the user perspective. And users generally try this for a few minutes, few hours, sometimes few weeks, and then they give their valuable feedback as to which of these configurations is more usable, and then those configurations are further evolved and taken for further, you can say, development process. Now, once this study was done, the actual prototype was built in order to test with larger number of users. If you really look at here are 2 versions of first industrial designs which came up. Left one is still little bit more on the proof of concept, but the one which is on the right is, you can say, a first industrial design version of the prototype which was built, where you can see the arrangement of the braille keys, the braille displays, the navigation buttons. They are all arranged in a particular manner which came through feedback from the users. And then this type of device is given to large number of users to try out and take their feedback for further exploration. So, there were a lot of comments, questions and critiquing of this particular device in terms of configuration, and hence and also people wanted to know what kind of colors will be used in the final. So, some color explorations were done, which are shown here as 3D printed refreshable braille devices was one of the exercises which was done. And what you see here is 4 different configurations were tried out based on the earlier feedback which came from the users, and each of these configuration was given to set of users to obtain their feedback, both short term as well as long term feedback. And then based on the feedback, the design underwent changes. Just like the earlier example of a smart cane, you see here too, the product goes through a multiple versions, starting from a proof of concept prototype to as the more and more industrial design aspects come into picture. For example, in this picture we are looking at exploration of a configurations, and in the previous one we looked at basically color explorations and form explorations, and all these things are combined, and finally the main, or you can say a final configuration, color and arrangement is evolved, and that's what actually goes for the design registration. So if you really look at this particular one, this is the final version, and in this version the design registration includes claims about not only the aesthetics, which are colors, but also about configuration and also in terms of form. All three are protected in this particular refreshable braille device. Then there was another version which was built. This one actually has a 20 character display, but there was also need for 40 character display with a different type of a keyboard, like a QWERTY keyboard, which was also built, and this is one of the very early prototypes of the 40 character display, and then this also went through the industrial design process, and what you see here is a final version which was again protected through another design registration. If you see, the two forms are very different for 20 character and 40 character. Their color is different and also their configuration. Hence, there is a need for two designs to be filed because each one is a very different, and two different design registrations were filed, and both were protected for these products. Now, before I conclude, I just basically wanted to summarize that industrial design is a fairly long process with lot of investment of time, money and manpower, but it also gives a strong value addition which needs to be protected through a design registration, and that is what most of the industrial houses and even the startups and small manufacturers generally do. And in order to protect an industrial design, one has to specifically look at what are the components which can be protected, whether it is the form or whether it's the color or color combinations, or whether it's aesthetic, or whether it is the, you can say, configuration of the product, and all these are important. And unless these are explicitly mentioned in the claims, one will not get a protection for all of this. For example, if you look at the second product, if second product is protected only from the, let's say, configuration point of view, then one will not get rights in terms of either form or in the form of aesthetics. So it's important that whatever is the new value which is generated needs to be protected, and we have also seen in some of the litigations which happened that the protection did not include all aspects, and people have to basically could not win the litigation because the protection was not complete in terms of its completeness was also some of the cases which we have seen, and hence it becomes very important to understand this aspect.